Okay, in this video I actually apply some more things I learnt while printing out the various cases. So I made some corrections to my ESP32 case that I went through on my last video, and then some of the learnings from that I applied. I actually made a OurBoatMonitor case as a prototype for the case to hold the components for the OurBoatMonitor together. I actually had 2 goes at that, so I learned a few things after the first time I made the case, and ended up with this is the ultimate case that I created. So things are looking good on the 3D printing and the case side of things. So I'm going to go back to looking at electronics after this video. Okay, before we start, just a little bit of screw theory. Screws have a major and a minor diameter. So the major is what they're measured as. So like a M2.5 would be a major diameter of 2.5 millimeters. The minor diameter is useful for when you're tapping out the holes. So in my case, I want to make the hole 1.9 or about 2 millimeters wide to tap it out successfully to a M2.5 millimeter screw hole. Okay, let's have a look at some of the corrections I had to make to my ESP32 case that I made in the last video. So my holes line up and I could use a tapping tool. This is a 2.5 millimeter screw tap. I've got 2.5 millimeter screws to go into those holes. So these tapping tools just screw down. You can sort of feel when you get to the bottom of the hole with the tapping tool, so you don't have to worry too much about going too far. You can feel it with your hands when you get in there. And the 2.5 millimeter screws fitted in successfully and tightened down okay. You can see where the USB is lined up at the moment. So this is one problem I found with my initial case design. When I tighten it up, because I didn't have screws on the front part closer to the USB, the actual board lifts up when I tighten down the screws at the back. So you can see here, I can no longer plug into the USB, it's just too high. So I need to get some screws into the front of this this case. So I'll add that into my design. So the things I've changed is the height of this. Over here I'll put a 2 millimeter hole in the middle. I raised this 3 millimeters, and the total height to 21 millimeters instead of 18. Okay, here you can see the changes I've made. So this front hole where I didn't have a place for the screw to go in, I've added a screw hole, and if we have a look at it, I've also made those standoffs 3 millimeters higher, and also the USB hole 3 millimeters higher, and the total case I increased that to 3 millimeters higher, so it's now 21 millimeters instead of 18 millimeters. Okay, here we see the resulting case, so a little higher. We have screws in the front and the back, so this doesn't move around anymore. The USB is nicely aligned there, and there's the case top that goes on the top and clips down. Give us a nice ESP32 case. That's all ready to go. Okay, I'm going to make a first case for this, so I've put some dimensions down on here. Here's the micrometer to get those dimensions. So the idea is I'll have my Pycom board and the GPS board up in this corner, so you can kind of think of a case being around here. 130 by 100 will be the size I'll make it. I can probably make it smaller, but this one's just a prototype case, and it'll also allow me to screw down some of these things while I'm playing with them. I'll keep everything about 10 millimeters away from the edges. I don't want to expose the GPS aerial. I won't be using an external aerial, so that can just stay internal. So this is the Pycom board. and then this is the power board that will take the 12 volt DC from the boat house battery down to 5 volt. They'll feed into there using one of these up to go in the end. Power will come in from the house battery through this external connector, will be on the outside of the box, go in there. Also have this battery backup, it'll plug in there, and I'll have some braces across here and screw a hole down across it to keep the battery down. That should be all the bits. This is the humidity and temperature sensor. I want that kind of outside. I haven't worked out how I'm going to do that yet, but probably be some sort of hole in the board and then have this attached on the outside with a nice cover over it, so I'll do the cover separately. But I want to be able to vent this one so that humidity can get to it. Okay, so I went to Fusion 360, took my standard case and then added the standoffs that I want for the OurBoatMonitor board, so you can see them here. I also put a hole in the end to put the aerial in. If we have a closer look at the sketch, you see it's all dimensioned with the location of the screw holes. So I'm going to print this off. It actually came out as a close to a 6-hour print, and then see how things fit on this first version of the case. Okay, here's my first prototype print of a case for my boat monitor. The way things should fit. This is really just to make sure the holes and things align. So it looks like I'm getting pretty close with the holes. I'll test it out. But I can put the Pycom board there. This is the power supply, goes in here. And I was a bit loose with the actual battery. I can move these closer together. The idea is that something goes over the top here to hold down the battery. Just seems a lot of wasted space too in the board, so I may do a version where I sort of put the battery underneath here, and then I can just make the box a lot smaller. But we'll see about that further down. So next thing I need to do is to tap out these and see what it looks like with when I start bolting things down. As well, I'll need to put this in, so it needs to be a little bigger, so I'm going to use this reamer here. Okay, that's pretty close. That will fit in okay. Okay, this is the whole thing screwed together. So these screw holes all lined up, which is good. This is in nice and firmly. This one, I found out the board actually uses a 2 millimeter screw rather than a 2.5. I couldn't put a 2.5 through the board. I don't want to drill out those holes. So when I redo these stand-ups, I'm going to have to make them for 2 millimeter holes rather than 2.5. This worked out okay for the aerial connector, and again this battery's hanging out here a bit loose, so I'm going to make it tighter, and I think I'm going to try and place it underneath that board like that. I'll put some braces around it, but the board's probably going to do a good job of holding it down. Maybe all I need is something to retain the battery in the back and front of it, and that'll work quite nicely, and then I can cut off this. Let's have it 100 square. It should still leave me plenty of room and save a bit of room on that. So I think I'm going to redo the prototype board just so I can screw things down before I start playing around with the electronics. Okay, so I'm going to make some changes here, so I'll get rid of these. Okay. Let's change my sketch. Okay, so let's modify okay, looking good. Now I just want to make some construction lines for where the battery's going to go. I'll use the exact size of the battery this time. I'll use the left side and right side Pycom board standoffs to position the battery, and then I'm going to add two more braces at the front and the back of the battery, which is actually going to hold the battery in as well. Now I need to resize the holes for the Pycom board, so they need to be 2M rather than 2.5M. So the inner diameter for 2M is about 1.9 millimeters, sorry, 1.5 millimeters. So I'm going to use the resizing tool to change that to 1.5 millimeters. And I've also changed the other two standoffs to 1.5 millimeter holes for tapping out to 2M screws. Okay, now I'm going to redo the extruding. I'm just going to extrude the screw hole standoffs first. I actually changed them to 10 millimeter to have them be a little higher so the battery can fit underneath easier. And then for I'm going to extrude the battery holders, the top and bottom battery holders. So that's looking good. So I think I'll just save that away as a milestone. And this will be the basis for the next print of my case to see if things fit better now. So that's saved. I'm now going to go to my slicing tool, which is Kara. So I select the body that I'm going to slice, say OK. I'll drop into Kara. And I just need to make sure that I put the base on the base of the printer. Slice it up and we should be ready to go. I actually say it's just over 4 hours, 4.5 hours to print this one. So this is the finished board. So everything this time is sitting down firmly. I've got the 2M screws holding this on properly now. The 2.5M screws for this power supply works well. This is the external connector, so it'll stay outside the case, and I'll put some little holes in there and probably araldite or super glue it in so it still stays semi-moisture tight. So there's two connectors for the house battery and then two more to sense the position of some water level sensors. Also I want to put the I2C sensor in. Like I said, I've still got to work that one out, but I'll probably fit it out here somehow and then put a cover on it to make sure it's vented to the open air. Battery worked out well. It's in there pretty tight. I can still use double-sided tape. Probably something I'll do later on is just move it down a little bit more, because get a bit more leeway to lift the battery out if I ever needed to change it. Aerial's in there good. I still need to work out the ultimate height of this box. It'll probably be about 10 more centimeters up here to clear all the Pycom and things. And I'll probably put a couple of lugs out here where I can screw this onto the actual boat. Maybe I put 4, maybe I put 2, maybe I put 1 in each corner here. We'll see.